Our lunch and learn today on AWS Cost Optimization. Thank you all so much for joining. In our discussion today, you'll get the chance to ask experts from AWS and Digicon your IT and AWS cost-related questions. So before we get into that, I just want to start with some introductions. My name is Zena, and I'm a Solutions Advisor here at Digicon. I'm also joined today with our two main speakers, Robert Pinder, our Cloud Development Manager here at Digicon, and Raman, a Solutions Architect from AWS. Before I pass it over to you, Raman, I'd like to open up the floor for some introductions. So if anyone would like to unmute themselves, feel free to share your name, your organization, and your reason for joining this lunch and learn today. I'm looking around and I see a few people have joined in on the listen only option. So if you'd like, you can take the time right now to rejoin with the mic on option, or you can just type into the chat, say your name and maybe what intrigued you about the lunch and learn, what you were hoping to learn. I'll give it a second. And it looks like a few more people are joining as well, so that's great. And if at all throughout the presentation, we do want this to be a little more of a discussion, so feel free if you would like to unmute your mic throughout, you can ask your questions then, or type any questions or comments into the chat space throughout the presentation. All right, I think we are good to go. Raman, I'll go ahead and pass it over to you.
Thanks, Gina. Good morning, good afternoon, everyone. Thanks for joining this lunch and cost optimization session. My name is Imran Rahman, Partner Solution Architect at AWS. And today we're going to dive deep into AWS cost optimization, how you can optimize your AWS cost spending. So without further ado, let's go ahead and get started. These are some of the common statements that customers make that typically trigger the need for optimizing cost. Many of these are usually a reactive statement, but we hope as you leave this session that you will be more proactive by building with the cost optimization in mind. So what is AWS approach around cost optimization? Robert, as you all know, we are a highly customer obsessed company. We work relentlessly to reduce our own cost and pass that resulting saving to our customer. In fact, we have passed the saving more than 67% of the time in the form of price reduction. On top of that, we also provide, from our expansive depth and breadth of services, we provide a lot of service around cost optimization as well as cost management. You have a service like Trusted Advisor, Cost Explorer, Cost Compute Optimizer, and Spot Advisor. And then on top of that, you also have a dedicated lab around cost saving. We call it as a well-architected cost lab. You can utilize all these for your own benefit to look into your overall spending and try to see what kind of optimization you can do in your AWS account. So there's a difference between cost optimization versus cost management. Let me first dive into these two. What exactly is cost management? When we are saying cost management, what exactly that means? Cost management is the ability to give visibility of cost to keep them under control and to enable cost optimization. On the other hand, cost optimization is the ability to run systems to deliver business value at the lowest possible price point. So now, keeping this in mind, let's look into what is the, can we move to the next slide? What is the best and good cloud consumption model looks like? As you can see from this slide, we have a blue vertical bar that showed you our consumption usage or cloud usage. We see a steady increase in a cloud usage over the time. And this could be due to several reasons. This could be because for a higher demand of your existing workload. This could be because of expansion in a different geographical region. Or it could also be because you might have migrated an existing workload from on-premises onto the cloud. These increased usage could represent business as usual or growth in the business. On the other hand, you can see the top orange line that indicates the unit cost. And this unit cost is based on your own KPIs. It's cost per transaction. You can see most of the time, over the time, it is either flattened or it is going down. And you can correlate why it is going down. It is going down because of cost optimization. So now keeping this in mind, let's look into what are some of the things, what are some of the pillars through which you can optimize cost. So before I dive into the 5 pillars of cost optimization, let me take a pause and ask, is there any question? Okay. So let's look into 5 pillars of cost optimization. The first one is right size your resources. Second one is increase elasticity. Pick the right pricing model. Optimize the overall storage solution which you will use. And the last pillar is measure, monitor, and improve. This will complement the other 4, the previous 4 which I have discussed. So now
and you'll notice this is a life cycle essentially. So while it's key to hit each one of these pillars, it's an ongoing cycle of review and improvement.
Yep, thanks, Robert. So yeah, let's look into each one of them one by one. What exactly is right sizing? Right sizing involves, can we go to the previous slide? Yeah, right sizing involves understanding the true performance needs of your resource and then sizing them to be the most cost effective. So what are some of the steps involved in there? The first step is selecting the cheapest instance while meeting the business and performance need. You can also look at your existing workload, look at its CPU, RAM, storage, and network utilization, and identify where exactly you can save. Let's look into some of the existing workload and identify, can you move the existing work to a different instance size and save cost? You can also get rid of resources that are underutilized or not used at all. This is the biggest pain point we heard from many of our customers who are running their workload into on-premise. They say, you know what, we don't know what exactly this server is doing. So try to identify on a regular basis those kind of a server and get rid of them if possible. Then the last point here is schedule resources to start and stop at the appropriate time. If at all possible, if a particular work is not needed 24/7, try to implement automation and start and schedule it at appropriate time. And it's not needed, turn it down. Now let's look into right sizing from an example perspective. So you have a workload, you're running in on-premise, you want to migrate on cloud. What you'll do, you'll look the closest instance size on cloud on AWS. So for the sake of example, let's pick M5 4X Lab. You identified that instance type and migrated your workload on top of AWS. The best practice says, after the migration, start looking into its performance metrics, like check its CPU, RAM, network, disk, and you can do this through our inbuilt service called CloudWatch. Using CloudWatch, you can monitor all the CPU, RAM, network, disk statistics. And then, as you can see from this, there are still plenty of headrooms available. You can see your existing M5 4X large server is not fully utilized. There are lots of resources underutilized. So what you can do is, the next step is, you can look into existing portfolio of instance type and identify an instance which can closely match the utilization, existing utilization. What you will do is, you'll right size the M5 4X large into M5 large. And then your job won't stop there. You need to again go ahead and review the performance metric. You need to ensure after the right sizing, your application is working optimally. After that, you will see you'll be getting a huge saving in terms of cost. As you can see, you'll save 87.5% in terms of cost saving, just switching from M5 4X large to M5 large. Any question here?
And I wanted to jump in and say, this is actually the most common example we see where people have an opportunity, 3 or 6 months after migrating a workload into AWS. It's very difficult just based off the the software manufacturer's recommendations to size a workload for a virtual machine, when most of those recommendations are based off of running on a physical machine where you need a lot more headroom. So it's quite often where people will do their best to size an example in a demo environment, and then when they run into production, they see something exactly like this, where there's good utilization of memory but way too much CPU, or just the opposite. And in this specific example, it's a very common one again, where we're staying in the same class of server, but what we're changing here from the 4x to the just standard large is the allocation of the resources that are actually needed by the application, which you can very clearly see when you look at utilization over a 3 or a 6 month period of time. And this is again a perfect example. If we can, instead of going for the really specific, I think this is a high RAM version, that's 77 cents an hour, we're able to run the exact same workload without any performance hit and drop our cost down to about 10 cents an hour. And that, especially over a 24-hour period over 365 days a year, that has a huge implication. And the perfect time to first take this right sizing is right after you migrate a workload. Set up and make sure you're monitoring all the statistics you want, so that in a month and 2 months and 3 months you can continue to check in and see, is there an opportunity to change the instance type in order to gain some advantage here.
Thanks, Rob. I can see from the chat, it seems that there's some difficulty around sound. Some people are not able to hear us properly. Can you all confirm you can hear me, and Rob as well?
Yeah, I think it's a few users trying to dial in. Nabila or Zina, did you want us to pause for a moment to give people a chance?
Yeah, sorry for that. The dial-in is not working. So if you can please join with your either the phone browser or your laptop browser, that should be good.
Okay, we'll go ahead and continue.
Okay, cool. Thanks, Rob. So the second pillar is increase elasticity. So what exactly does that mean? Elasticity involves being able to scale your workload based on demand. This is important. This is very important. Let me tell you why. Because this ensures you're paying for only what you consume. You're moving away from CapEx to OpEx. You're not spending a lot of money and procuring server. It's just as simple as that. When you need it, increase your server count. And when you're done, just terminate those. AWS offers several services that offer efficiency and this capacity management through a service called EC2 auto scaling. So now let's look into how you can use EC2 auto scaling in a capacity management conversation. So this is how the traditional approach to capacity management. When you have to do capacity management, you start looking into the existing workload and you look into the historical data of last 1 year. And then based on that historical data, you identify the peak usage. And then based on that peak usage, you set your capacity. But the issue with that is when your workload starts running on AWS, then what happens is you rarely reach to that full capacity. And when you reach it for a smaller period of time. So what happens because of that, most of the year, you're spending a lot of money and most of your resources are running or sitting idle. The other approach to that is you can look into your historical data and you build your capacity based on average utilization. Now, the other downside with this approach is when your application reaches to its optimal capacity, you don't have enough room or your application won't have enough capacity to work. And that eventually cause some kind of outage. And in some certain extent, it can cause like your downsize in your revenue. I mean, it will affect your revenue cycle. So what you can do to mitigate these two approaches, you can use AWS EC2 auto scaling. So let me explain. Can we move to the next slide, please? So AWS EC2 auto scaling is a feature that allows you to scale your existing workload based on its own demand. You don't need to manually go ahead and enable or plan capacity early and then go ahead and manually enable it. What you can do is based on certain metrics, you can enable auto scaling. And the moment your existing workload need or demand additional capacity, it will go ahead and add those capacity on behalf of you. And then when it's done, when the load goes down, EC2 auto scaling feature is intelligent enough that it will identify and look into the operational metrics. And if it goes down beyond a certain threshold, it will go ahead and terminate it. This ensures you reduce over provisioning, and this ensures you are not spending a lot on overcapacity. Can we go to the next?
Yeah, just to pause for a moment here. For anybody a little less technical on the call, really the idea here is when you're running either a physical workload or co-locations or virtual machines or whatever, the intention is you need to buy enough hardware to meet your maximum capacity, your maximum need. And so you're paying for that hardware as a capital expense. And just the move to the cloud changes you from that model of a capital expenditure and worrying about having that extra capacity. You're moving to an operating expense model. And so your desire from a technical perspective is almost exactly the opposite. Instead of making sure that I have a server that's got enough extra capacity to meet my needs, in a worst case or an almost worst case scenario, immediately your first idea is, well, let's move down to what the minimum need is, and auto scaling adds on top of that. Instead of just the minimum need to meet all of my capacity needs, what I'm really trying to do is what is the very minimum unit that I can get away with to make the application function. And then when I have additional load, I spin up 3, 4, 5, 100 of these, depending on your need and your application, just while it's needed for usage. And then it drops down to that single instance, just waiting there to accept the next connection. And so it is a very different way to look at your server application. But auto scaling in EC2 is very simple from how it handles the EC2 instance. And one of the strengths of Digicon, coming from our heavy networking background, is simply by putting in front of the servers, load balancing systems, systems that try and balance between multiple units. Most applications can pretty easily be enabled to allow this sort of elasticity, where you can go down to a single tiny little server in order to run pretty large scale applications, and then using the auto scaling easily spin up hundreds of units when you need them and drop them back down to the tens or 1 or 2 that you need running. And it doesn't take as much upfront work as people think that it does if you look at it from the networking perspective for the load balancing portion. So didn't want to lose that thought while we were on this. This is a very, very valuable look at how to save, and it doesn't take as much investment as people think in order to enable auto scaling for many applications.
Thanks, Rob. Thanks for bringing that point in here today. So let's spend some time and let's ask from the people, from the attendees, how many of you are currently using auto scaling feature in your existing AWS account? If you can type your response in the chat, that would be great. Mark saying no. Mark, can we know the reason? Is it like something you all don't know, or is it like too tough to implement? Oh, got it. Got it. Thanks, Mark. All right. So yeah, let's look into the third pillar. The third pillar is, Rob, do you have any
I was
comments?
just going to add, that's a normal response, Mark. And actually, this next pillar is probably more aligned to you if you've got standardized workloads that are pretty steady, but aren't necessarily needing an auto scaling. So the next pillar is probably perfect for you.
Thanks, Rob. Yeah, so the next pillar is leveraging the right pricing model. As you can see on AWS, you have various pricing options available for you to pick and choose from. The easiest and most simplest is the on-demand. The on-demand is the pay-as-you-go model, wherein you can pay for your use capacity based on hours or second, depending upon the instance type you're using. Then you also have an option called reserve instances and saving plan. These two goes hand to hand. There's a slight difference between these two. Saving plan is, and I have a dedicated slide wherein I'll explain the difference between that. So for the sake of time, let's for now understand what is the difference between two. Saving plan is more flexible as compared to reserve instance, where in reserved instance, and I'll say in both, we need commitment. If you know that you have a particular type of application that required a consistent amount of compute workload that can run for a prolonged period of time, I would say like 1 year, 2 year, or 3 year, then you can commit to AWS saying, hey, I need this instance size for next 1 year. And in return, you'll get 60 to 70% discount on top of AWS on-demand instance price. Now, there's another option called EC2 Spot. It's kind of a cool pricing strategy, which I would like to discuss here as well. In short, it's like a huge topic. If we want to spend, we can spend entire session on that, how a spot instance works. So I'll try to be brief here. So if you want to use an unused capacity from AWS, you can opt for EC2 Spot instance. The only thing you need to keep in mind is when AWS needs or somebody else needs that capacity, we'll give you 2 minutes warning. And during that 2 minutes, you have to ensure you need to terminate your application. The good thing, go ahead, Rob.
Yeah, I'll just jump in real quick. To me, the easiest way to think of these three different models. So on demand is what you do by default when you turn on a service. And so while that's the most expensive, it's reasonably priced. It's less than, run virtual machines in your own environment. And that's what you're typically involved with is your on-demand pricing. And as soon as you see that you have a consistent workload of some sort, then you should start looking at either reserved instances or savings plans. So any system that honestly runs 365 days a year, your AD servers, your DHCP servers, just your standard infrastructure, that stuff, you should look at reserve instances and savings plans because you can make a commitment based off of that usage. And spot instances are great, especially for the developer community. What that really allows you to do is at an extremely cheap price. If you've got workloads that it doesn't matter when they run, just that they do run, spot instances are very, very inexpensive because you can just kind of ask the marketplace, hey, what is available? What's my price right now for this instance type? And if it's cheap enough, you quickly spin up an instance, run your analytics or whatever is appropriate for it. And then, it's no big deal if that system has to be terminated because you've got, 24 hours or 2 days or whatever to run this particular workload. So it does require thought and, programming, but the cost difference is tremendous. It's literally just using excess capacity in the cloud whenever it's available. So if you kind of just think of your workloads as one of those three types, that's a big key in setting your baseline price for any particular workload.
Thanks, Rob. So yeah, and as Rob said, most workloads start off as an on-demand workload, meaning you pay for what you need at that particular moment of time. So now, as I promised, let's spend some time and understand what is reserved instance and what is saving plans. As I told you, both are exactly the same. The only difference is with reserved instance, you are tied to a particular instance type. With saving plans, you get more flexibility. You're not tied to a particular instance type or a region or a class of instance type. You pick a broader saving plans, and through that, you can pick and choose any instance in a particular region. Treat this reserved instance or saving plan as like a discounted coupon. It will be applied to a particular instance when you run it, and it will reduce the price hourly. So for example, you're running a workload 24/7, 365 days. Each RIS gives 1 coupon per hour per instance during reserved instance over the time. And with that, the advantage is you will save up to 5% of your savings.
So roughly the difference between the two is that, if you've settled on my DHCP server needs this particular instance type, that's a function isn't going to change over 3 years. So that's a reserved instance example where I know exactly what kind of server I want this to run on, and I know I'm not going to make any reductions in the amount of spend I'm going to have with that particular instance type. And so I can commit to 3 years. Another benefit of this is if you can standardize on a couple of instance types, then servers that all use that instance type will get this reduced cost. And typically when we see people use this, we see them commit to 3 years. And so the savings are very high. And then on the savings plan, it's more along the lines of, if my business knowledge, what I know is that I'm going to be able to commit to a certain dollar amount, that's when you want to look at savings plans, no matter what the particular details of the services that you're buying.
Thanks, Rob. Yeah, let's move into the next pillar, that is leveraging the right storage class. AWS offers many types of storage based on its application needs. So it is very important to pick and choose the right class of storage and right type of storage. So there are multiple storage types available nowadays in AWS. So let me go one by one and explain what are those. Can you go to the next slide, please? Yeah, as you can see, we have, before I go dive deep into it, let me ask you this. How many of you know what is the difference between block storage versus object storage versus file storage? Okay, so let me explain that. Block storage is a kind of a storage architecture wherein the data is split into fixed block, and then it is being stored into storage subsystem along with a unique identifier. Now, when you need it, when you try to access those data, there's underlying storage subsystem and the operating system will try to find those data using those unique identifier and then assemble it back and present it in front of you. Treat this block storage as like the VM in your on-premise storage attached to your VM or physical server. So when you have a physical server, you attach a particular kind of a storage with that and then deploy your operating system on top of it. That is block storage. In AWS, we have a dedicated service called Amazon Elastic Block Store, which you can use for that particular purpose. Now, the next storage type is object storage. And that object storage is in AWS, it is Amazon Simple Storage Service. Now, let's understand what exactly is object storage. Object storage is a kind of storage architecture wherein your data is treated as a single entity and it is being stored in its own separate housed along with its own metadata and unique identifier. There's no hierarchical file structure. So you don't have slash data or anything like that or root or kind of a thing. Everything is in a flat structure. This is more suited for your CSS file, static content, images, data file, backups. We do have a tiering in that as well. So it doesn't make sense for you to pay the same amount of money for a file which you want to access frequently versus a file which you have taken archive 3 years back and you don't need that file in next 2 to 3 years. What you can do that, you can enable intelligent lifecycle management on top of S3. And what it will going to do is anything which is not being accessed in past 30 or 60 days or whatever, it's a highly configurable feature wherein you can set your own time. And then if you haven't accessed that particular file during that duration, it will automatically move it to Amazon S3 Glacier, which is archival storage. And through that, you can get a lot of cost saving. Now, the third option there is file system, Elastic file system, and that is like a file storage. What kind of a storage architecture is that? Elastic file storage is a kind of a storage architecture wherein you store your file in a particular directory. So treat this as your NFS or NetApp appliance, NFS appliance, or NAS appliance inside, not NAS, NFS devices inside your application or inside your data center. In AWS, you have a service called Amazon Elastic File System or EFS, which you can use it for shared storage. This is typically wherein if you want to share data across multiple instances as an NFS, so you can use that. Rob, do you want to add anything here?
Yeah, we've got a few less technical people and more business minded. So I always like to give people a way to think about these three concepts in storage in a more business sense. So as Ramon said, block storage, I actually think of this as a physical hard drive, connected to my laptop or my server or whatever. And that's probably the best way to think of those items that fall into block storage. When you're storing things in that way, you actually do need to be concerned about things like, how am I going to back that up? How am I going to restore it? Is it encrypted? What happens if it physically gets damaged or lost? It kind of in those ways, you have to think about a hard drive in those terms. That's your block storage. And as Ramon pointed out, depending on whether you're using EC2 instances or whatever, there's a couple different options there, but pretty much what you're doing is attaching a virtual hard drive to a virtual machine. And that can represent, SAN storage, where Amazon is doing a lot of work to replicate that in the background and make sure it's available and fast for you. But there's no guarantees or smaller guarantees of the ability to recover it. If you change that file, it's not automatically backed up for you in any way. So you do need to be concerned about backup software and that sort of thing. Then we move into the file class. And, as it says here on the slide, this is your distributed file systems. And in the server world, in the Linux world, and so forth, that's primarily represented by EFS, which is a standardized service that those guys are regularly concerned with. In the Windows world, where a lot of us on this call are, that's my Windows shares. And Amazon, not listed on this slide, has an excellent service we use regularly to replace all file servers. We rarely implement file services when we've moved a customer over into Amazon. Instead, we use this service called Amazon FSX, which provides those file service capabilities and allows you with, point and click capability. I want this backed up every day and keep it for 30 days. Those sorts of things are just built into it. And you can pick and choose whether or not it's in multiple data centers or multiple regions. So you're less concerned about directly backing up, a quote unquote physical drive. So that's the way to think about everything in that file services area. And then object storage is your most efficient, least expensive, but not quite as simple service. That's really everything you can get to function in the object storage area, you should. And this is Amazon S3 and a ton of services built around Amazon S3. And it allows you to manage your data by policy instead of thinking about servers and that sort of thing. You're literally writing policy, where I can just write a simple statement that says, if this file or this object hasn't been accessed in 30 days, move it over to Glacier storage, where it costs me a whole lot less because I'm not likely to ever have to get it. I'm saving this information for compliance reasons or backups or whatever. And depending on your particular environment, a lot of services are built to directly interact with S3. And if you're running, on-site SAN systems, there's a lot of management software or SANs that have built-in integration with Amazon S3, where that physical piece of hardware in your, data center can participate in that policy management, where it's files that are like block storage or file storage to your data center, and yet when it reaches a certain status, it's going to move over to Amazon in order to reduce your cost, and means you need to buy less storage on site. And then while it's sitting in Amazon and it doesn't get accessed for another 30 days, it's going to move over to Glacier storage, where maybe it's going to take an hour to reconstruct that file and get it back to you if it needs to, but it costs you, like 100% less. So this is a storage. If you can think about, if you're at the point with Amazon to think about storage in these ways, it is a huge opportunity for savings, especially in the enterprise.
Yep. And thanks, Rob. Thanks for bringing in FSx. That is a really great option as well for the Windows-based workload. In fact, if you want to use FSx for Linux, you can use that as well. Just wanted to point. Cool. So now the last pillar in terms of how you can do cost optimization is the mechanism for cost optimization. And this is, I would say, essentially a mechanism and process and tools that complement the other fours which we have discussed so far. So let's dive deep into what are some of the mechanisms you can implement. The first one is you can define and agree and enforce cost allocation tagging. So what you can do, for example, you have let's pick an example for this one. So in your you are a big, large enterprise customer, and you have different team in your company. So tomorrow, if a team comes to you and say, like, hey, you know what, I have this AI/ML hypothesis which I want to work on that, or this AI/ML feature which I want to test, and whether to test whether this particular job will gonna run or not. You can go ahead and create account in AWS, and just to ensure that particular team is using that particular resources, AI/ML capability really well enough, you can enable tagging so that in future, if you want to go and identify who is using what service, you can get it from the cost. So you can enable tagging based on your cost company cost centers, and you can enable on the AWS account. You can also, the second thing you can do is you can define metrics. And based on that metrics, you can set targets saying, okay, you know what? I want to set a metric saying that any servers in my company, which is 75% or less utilized, we'll go ahead and look into it and try to right size it. And do this frequently, not like every 6 months. Try to do it every quarter and assess your workload. Then enable your team to architect for cost. Try to provide them this kind of lunch and learn various AWS best practices, one deployment guide, sending them to training around cost optimization, those sort of stuff. And lastly, assign optimization responsibility to a particular team. Make a dedicated focus team and give them this optimization as their priority task, and have them look into all these four other three pillars and try to optimize overall cost.
And I wanted to add in, especially on this enabling teams and assigning responsibilities portion, one of the key things here is to make sure that you have stakeholders from the business as key members here. Maybe even at the stage where you're defining your tagging and what your cost centers really are. What that enables you to do is to define things in business terms or organizational terms for our government customers here. So that you're instead of thinking of tagging along the lines of, this is my Active Directory server and here's all the storage items and network components involved in running that Active Directory server. That's not how the business thinks about it. They have a budget for a project and they have a budget for overhead. And so you want a tag associated with the business needs and get all the components reporting in that way. And so as early as is relevant, bring your business stakeholders into these technical meetings as you're defining what components or what those tags actually are. Because what you measure is what you're going to focus on. So that's really important.
Thanks, Rob. So yeah, let's move now from cost optimization to cost management and cost visibility. How can you look into your overall cost? So we have several tools available for you for that. So let's look into it one by one, starting from the left all the way to the right. So what is AWS monthly invoice? AWS monthly invoice provides you a view once a month and break down cost by services. On the other hand, you have another service called AWS Billing Console. So through AWS Billing Console, you can get a more granular level data around your AWS consumption. For example, you can get what is your from AWS Billing Console, you can get what was your last month spending, what is your month to date spending, and based on that, it will forecast you what would be your upcoming bill. You can also drill down based on the services through AWS Billing Console. And then the third option is AWS Cost Explorer, and we will dive deeper into each one of them one by one. And AWS Budgets, as Rob mentioned, around setting budgets. We have that option in AWS through which you can set budgets, and then that can give you that can send you alerts the moment you exceed your budget amount. And then lastly, you also have an option to use third-party software or third-party tools for your billing needs. If you want to, if you are a huge organization and want to look into multi-account strategy, you can, and if you want to use your own dashboard and third-party tools, you can use that one as well. If you go to the next slide. So this is how your AWS Billing Console would look like. As you can see on the right-hand side, you have various options from which you can select budgets, you can get budget reports, you can get the spending summary, and then you can also get month to end spend by service as well through AWS cost management, billing and cost management service. Now, what is AWS Cost Explorer? AWS Cost Explorer is an easy to use interface that lets you visualize, understand, and manage your AWS cost and use it over time. It's very intuitive and very user-friendly through which you can get started quickly. Using AWS Cost Explorer, you can set time intervals and granularity while getting the data. You can also filter your workload based on tags, grouping, availability zone, those sort of stuff. And then if you need, you can save your progress as well. And finally, if you want to access data into some other subsystem or system to do some data crunching or try to get prediction using big data analytics or AI/ML, you can access data from that using programmatical way as well. I don't want to spend much time here. That is like how you can access your AWS Cost Explorer. So let's move into the next slide, please.
Yep, and every other slide, and this is going to give a little bit of detail to what Romano's talking about. We're going to skip every other slide, but we'll send out the presentation to everyone if you want to actually explore in your own console.
Thanks, Rob. This is how you can, typically your Cost Explorer would look like if you want to filter it. As you can see, you can get granular level access by EC2 instance. If you have any other EC2 which you want to visualize, you can look into various services. And very important thing I would like to call out here is the filter option. You can see you have tons of filtering option available. You can filter this by service. You can even filter this by tag, which we discussed earlier. If you have certain cost center, you can tag the workload based on that cost center. And now when it comes to reporting, you can come here in AWS Cost Explorer and filter those using cost center as well. Now let's look into budget. And this is very important. Rob also touched here. Yeah, treat budget as like the normal budget. You want to set a budget for a particular account and workload, and you want to be notified when you exceed or forecasted to exceed. You can do that through AWS budget service. How does it work? You need to set budget, and then you need to set alerts on top of that. And then the moment it will, about the particular workload or account is about to exceed that budget, it will send you an email alert. What kind of a dimension can we use to create a budget? Like typical other AWS services, you have various options to pick and choose from in AWS budget. You can pick a particular service, a region, an account, those sort of stuff. Then the next question you might be asking, how many budgets can I create? You can create up to 20,000 budgets in a particular AWS organization. And that is not a hard limit. It's a soft limit. If you need, let us know, create a ticket with AWS support, and we're gonna go ahead and increase that. Just to let you know that AWS 20,000 soft limit, it's a huge amount of it. And we hardly see customer coming up for a quota increase around budget because it's 20,000 budget limit is too much. So we don't expect you, but just wanted to let you know that that is an option available for you. If you ever exceeds that quota, just let us know and we will go ahead and increase it. So can we move on to the next slide? This is a high level how you can set budget. You can see you can set budget based on cost, usage, reservation. You can even set budgets onto saving plans as well. Now, the last kind of a tool or service which you can get from AWS through which you can get cost visibility is AWS Trusted Advisor. It is a tool that provides guidance following AWS best practices. It has lots of checks, and it does that through lots of checks. It has cost optimization checks as well, performance checks, security check, fault tolerance, service limit check available. We highly recommend you all to look into this often because it's not only give you a recommendation around cost optimization, it can also give you a recommendation around your security posture. If you have something vulnerable open, for example, an ES3 bucket, it's publicly available, which accidentally you have opened it, it will identify those and flag you. So we will highly recommend you to go and look into Trusted Advisor frequently. I would say, in fact, I would say bi-weekly. Now, in Trusted Advisor, we have a cost optimization checks enabled. So you can go ahead and enable that. And through that, you can get understanding and visibility around potential monthly saving. What are some of the instances that are underutilized? Can we go to the next slide? Because that would be, but yeah, here. You can see it will give you a recommendation around underutilized resources, ideal resources, and it will even give you RI recommendation saying if you'll replace this instance and opt for RI, you'll have a potential X amount of dollar as a monthly saving, as you can see here. So these are some of the things you can achieve using AWS Trusted Advisor as well.
And one thing I always like to leave people with related to Trusted Advisor is, if you've got a team that meets regularly, either for change management or, reviewing monthly patches or anything where you've got your team meeting on a regular basis, whether it's, bi-weekly or monthly or whatever it is, Trusted Advisor just running this before that meeting so that people can walk in there with, quick things to review that are, cost, performance, etc. related. It's a great tool to, prepare your engineers before that type of meeting.
Thanks, Rob. With that, I would like to hand it over to Rob for a use case around how Digicon has implemented some of these best practices and cost optimization for their end customer. Over to you, Rob.
Thanks, Raman. So that's kind of the point of ending this here is, what's Digicon's role in all this? We've talked a lot about, what existing AWS customers or people who are preparing to move a workload into AWS, like what kinds of things you can approach, and some of these are even long-term, regularly reoccurring things. And so one to add in there, typically our customers fall into two categories with, Digicon and AWS. Maybe you're deeply into AWS and running your own environment, and you're treating us as, a place to purchase and to get discounts for your usage. and then occasionally advising you on new products that might be appropriate for your needs. And then the other set of customers are really engaging with us on a project, either moving a particular workload into Amazon, or improving their security stance, or enabling a remote workforce. And what Digicon has done over the past several years is we've taken all these use cases that we regularly run into with customers, both in the cloud and also where we're running their on-premise environments or operating co-location environments for them, whatever their particular need is. And we've integrated these cost optimization methods into all the different stages of these various plans. And in general, you can kind of look at them, or our view is you can look at them as 4 stages. Every single time that you are looking at an application to move into the cloud, we've got a set of documentation to walk you through a project to do that in the best way possible. And generally what we look at in the cost optimization area, that is, when you're looking at a particular application, if you can identify a SaaS application for that. So this is your Salesforce automation applications, where there are options to run things internally, or you can go buy a SaaS application. Typically, your SaaS applications are going to be the most optimized for cost and performance. They're betting on the benefit of serving a lot of customers with a common app. If you can't find what it is that you need as a SaaS application, then go look at the AWS marketplace. Maybe Oracle or Salesforce or WordPress or whatever your need is has already created an AWS integrated version of their application, and they're offering it in marketplace. If you can't find that, then go look for AWS services that meet your particular need. So this is an example we were talking about earlier, where if you're running a bunch of file services, you should be running Amazon FSx instead. It's much cheaper. It covers all your backups. There's lots of benefits to it. So that's a great example where Amazon has built a service around something really commonly that people need to use. And so a lot of your benefits are built into it. If you can't find an AWS service that exactly meets your need, you can always fall back on what I call AWS infrastructure as a service. And this is a lot of what we talked about today. Your EC2 instances, what kind of storage you're using. For those of you not in Amazon today, this is your virtual machine environment. I can run almost any piece of software as a virtual machine. And in the worst case environment, where I've got some really specialized software, I can always run Amazon bare metal. Other than in the science field, I've never had a customer actually need the bare metal requirement, but Amazon supports it completely. Then the second area is after you've moved or you're operating something in AWS, optimize that for performance. Don't worry too much about your cost in your first few months. Optimize it for what it is the application is supposed to do, and then measure your actual usage. Then comes stage 3, which we talked a lot about, the AWS tools and things as simple as reserved instances. Just identify what your workloads actually are, and that's going to tell you a lot about how you should be purchasing it. And these kind of things, you don't have to wait long to do it. 3 months is plenty of time to get a good view of what your workloads are going to be to start making these decisions. And then the last one is bigger. You got to be a little further along in your cloud journey, but consider fundamental changes to the way that you do IT in order to align your cost with your business benefit. And this could be developing some custom applications that are using Amazon services. In bigger environments, this is where we're talking about artificial intelligence to analyze data. And moving systems off of dedicated databases into Amazon RDS services, these kind of things. Like we talked a lot about, is if you can stop using block storage and move to closer to S3, your cost savings will be immediate and large. And the biggest one a lot of people really don't realize is how much money they spend on software licenses to the, the Microsofts and the Oracles of the world. That stuff's all built into your cloud purchase. The more you're buying, even EC2 instances, it's including cost for your software licenses. Make sure you're recognizing that savings that you're realizing in your budgets going forward. And basically the message I guess I want to leave here is that Digicon can help you out if you're sophisticated and you operate your own infrastructure, and we can be here and talk to you at that technical level. We've got the engineering staff to do that. And more often, we like to integrate with the customers who want to do less hands-on and want to really gain the benefits of common services and approaching things from the right way. And the best customer is who is just beginning their cloud journey, where you're ready to move out of operating servers in your own environments or in co-location and to move into the cloud, because you could take advantage of every step here, both for cost, performance, and reliability. So that's what Digicon's here to do, whether it's augmenting your staff or just acting as an advisor for you to help you make the right decisions. With that, I know we've lasted a while, but if we've got any questions, now's the time. We've got a lot of people in chat, so feel free to put any questions in chat, or anybody else, just unmute and we'll answer your questions. Lucia, Zena, did you want to add anything?
No, Rob, I just wanted to thank you and thank Ramon for that presentation. It was really great. So thank you to you both. And yeah, like you just said, if anyone has any questions, feel free, type them into the chat, or you can unmute. We'll give it a second or so if anyone has any questions.
I'll also add that we have recorded the session. I know a few people early on were having some audio issues, so we have recorded it. And for everyone who attended, we'll send out both the presentation as well as a link to the recording if you missed anything.
All right, and one other thing I wanted to add is that I think the next best step for everyone that's joined the presentation today would be to set up a free consultation with us. We'll get the chance to sit down with you and our engineers, learn a bit more about what you're looking for, and address some of your more specific concerns. So you can feel free to reach out to myself or Luch. Our contact information is up on that screen, and we'd be happy to set up that consultation with you anytime, so feel free to reach out to us once again. But thank you, everyone. Thank you, Rob. Thank you, Ramon. And thank you, everyone, for joining. And hope you enjoy the rest of your day. Thank you.
Yep. And yeah, this is Ramon. I would like to thank everybody for your time and participating in this Lunch and Learn session. If you have any question, feel free to reach out to Digicon team, or if you want, hit me directly as well. Looking forward. Thank you.
Actually, Ramon, if you want to go ahead and type your email address directly into the chat, that would be great.
Sure.
For anyone that wants to reach out to you.
Awesome. Thank you.
Thank you, everyone. Thank you both.